Well, here we are. Unit 6 review. Test is in a couple of days. So, yeah. If you got questions, just use the chat there. You could use Remind app. I have my phone up and running here. And yeah, we'll try to go through this. Be brief, be quick, and you know the drill. So, let's just begin. So, doop, doop, doop. All right. So we've got a little model of an atom here, and make sure for the test that you can, you know what, let me just real quick, I'm just going to run this over here, make sure that we're doing okay here, how we're doing on our health here. Looks like we're pretty good. A little bit of a review, a little bit of a thing. Just let me know if it is bad. Hey guys, what's up? Mia and Aiden, how's it going? So anyway, let me know if the stream is bad or if it's choppy or anything. I'll restart it, but I'm just gonna jump into it. We've done, not our first time doing this. So anyway, you need to be able to know what these things are. And so obviously this is not really a multiple choice question here. Hopefully you're looking at this and you know that A is an electron. All right, I'm gonna just so I could get better. Electron, and it is negatively charged. B, it says assume B is neutral, so that means that's going to be our neutron, which is neutral. What are you answering, Noel? I'm not sure. D then is, yeah, what is it then? Well, it's going to be a proton, because that's got to be the positive thing there. Wait, oh, see, hey, hang on, wait, let's just scooch that down. I'm going to actually, that is not a proton, because C is not pointing to what I thought it was. Got to look a little closer, Miss Jern. I don't know, Noel, it's 7 o'clock on a Wednesday, who knows, it's okay. I just made a big mistake too, because C is not pointing to what I thought it was pointing to. C is pointing to this whole entire thing in the middle there. And that whole entire thing in the middle is, as you probably know, the nucleus of the atom. Now, I'm not, hello, I could spell. I'm not saying you have to know exactly, about this, but that's a U. I'm not gonna erase that now. Hey, Chloe, what's up? How's it going? The nucleus is made up of, I'm glad you can make it, actually. I didn't know you guys knew about this, so awesome. The nucleus is made up of the protons, which means it's going to be positively charged for the nucleus. And that brings us to letter D, which is the protons. And that's going to be the individual part of it. It's going to be positively charged. So if B is neutral, then C has to be the proton. Holy cow, D has to be the protons. That's what I get for doing these out of order on purpose. C will be the nucleus. That's going to be all the protons and the neutrons together. So overall, the nucleus is going to be positive. All right. So just make sure you know that by the back of your hand, and you're going to be good with that stuff. So also, I think I might ask this in the next slide. Yeah, nope. Make sure that you understand too that the only thing that can leave the atom is the electrons, these things, because they're on the outer part of it. And remember the example I gave you, I don't know, like a long time ago, this nucleus right here is very, 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 very small compared to the where the electrons are at. So all these protons and neutrons are packed very tightly, very densely in the center, and they're stuck. They cannot move without some kind of nuclear reaction, which is not going to happen, on a typical day. And so the only thing that can move are these electrons. So, and actually it's usually the outer shell of it, like this one that it's actually pointing to. These inner electrons would probably be stuck. So, see, it's a good question, Aiden. I'm glad you asked that. I would say no, again, without a nuclear reaction, because losing protons would be nuclear fission, and gaining protons would technically be nuclear fusion when you combine the nuclei together. So I'm just going to put a hard no on that for our purposes. We're talking just about electrostatics. Okay, so no, it can just consider the protons are stuck for our purposes. All right, good question. All righty. So moving along, and like I said, if you got questions, just let me know, and I'll go back to it, because we always have a little bit of a delay in this, just because that's just how it works. All right. So again, let me know if it gets choppy or if anything's wrong. I will just quickly restart it, and it should reset it. At least it's done that in the past. So, all right. So hopefully, you can answer this, by the way, A or B. We can see. We said these are neutral, so B is neutral. These are the neutrons. I spelled that wrong. No, I'm not sure. Holy cow. I'm also writing kind of sideways and whatnot. Is it neutral or is it charged? Which means that these are going to be the pluses. I should just put plus right there. That would have been a lot easier. These are the minuses we said from the last slide. And it looks like, so we've got 1, 2, 3 negatives, and we got 1, 2, I would say, I was right the first time. Thanks, Mia. All right, I'm going to fix that, because otherwise I'd be embarrassed forever. It is neutrons. And it looks like we got a little guy hiding back there. That's going to be our little positive. And I can't tell. I think this is going to be the same like proton hiding back there. So based on what I could see, it looks like, and let's just assume that I'm right, and we got another positive back there. So we've got 3 negatives and 3 positives. So yeah, it looks like it's going to be neutral. You guys are saying A, and I'm wondering, let me erase this a little bit over here. I'm wondering if you count, and again, it's going to be way clearer on any test questions, all right? But I'm seeing a little smidge right here and a little smidge right here, and I think those are the same protons. So I get what you're saying, and so it looks like it might be charged, but it looks like it's the same proton back there. Yeah, I mean, basically what I'm seeing is we got 3 positives and 3 negatives, which means it's going to be neutral. Holy cow, it's spelled right here. I'm right there. So it's going to be neutral because we have the same number of protons, positives, as we do electrons, negatives. It was green, I thought it was purple. Yeah, so, well, I know. This is a kind of a bad drawing. Like I said, in the test, it'll be a lot more clear. What you're looking for is just compare. How many protons do we have compared to how many electrons do we have? In this admittedly sort of terrible example, we've got 3 positives and we got 3 negatives floating around the outside. Okay, the negatives are pretty clear. Definitely negatives are there's 3 of those, and it just looks like to me we've only got 3 positives in the middle. But again, this is sort of a ambiguous diagram. Okay, got it. All right, cool. So we are going to move on, unless there's any other questions. We could always go back to that. So now we're into the multiple choice part, and before you see what everybody else is guessing, what is your guess as to make this atom become charged? It doesn't specify positive or negative, so which one is it going to be? I'm going to sip my tea like Kermit. All right. Choose more than one. I don't know if that helps. I'm just going to go through, and I'm going to start at the bottom. Are we that much of a delay? We'll see. All right, so I'm going to say you can't gain or lose neutrons, okay? You can't gain or lose protons because those are just stuck in the middle, like I said. Those are stuck in the middle. And so the answer is, yeah, A or B. So you can either gain or lose electrons, and that's it. That's it. Gain or lose electrons. So if you lose electrons, it's going to become, I'll pause for effect. It's going to become positive. And if you gain electrons, the thing is going to become negative because now you have extra electrons, and so now you're extra electron-y, and so now you have more negative. If you lose electrons, you are short some electrons, and well, that's okay, Aiden. I got what you meant. A or B. I know what you meant. Okay, on this case. So yeah, that's how it works out. Bink. Okay, why does a charged balloon stick to a neutral wall? Yeah, same difference. So for this one, you could eliminate some. Hopefully you eliminated that the wall is actually positive because the wall is definitely neutral. The wall doesn't lose atoms. That doesn't do anything. The only possibility is that the wall could maybe lose electrons, but you're not rubbing it or doing anything like that. So yeah, it is going to be B. There's this word polarized here, and that might be throwing you off because of the definition of the word polarized. Now, if you could explain what's going on, that would be ideal. And had I thought about this, I was just like, oh, I'll just draw it. But I could have pulled up that PhET simulation that you did. And so I'll just draw what I was originally planning on drawing, where you have your wall and you got positives and negatives and positives. And overall, it's going to be pretty neutral. And I'm not sure what I was planning. That's an X. I'm not sure what I was planning on doing here, but basically, so it's neutral, right? And you've got your balloon that is negatively charged overall, okay? And you bring it closer to the wall, and what happens? Well, man, I really wish I would have got that PhET simulation going. These negatives, they will all scooch over and get pushed away over here, and any positives that were here, they don't move. I just added that one. Any positives that are there is going to cause our balloon to basically stick because it's going to be affected it's going to be attracted to those negatives in the balloon. So the balloons push these electrons away, and that leaves the positives nearby to attract the balloon to it. Okay, and with the inverse square law for distance, the positives are able to hold the negatively charged balloon right there, and it doesn't fall for a little while. Okay. I mean, drawing a picture would be amazing, Mia, if you can. The picture just like this, but also explain. I mean, assuming it's going to be a question where you get to explain it. But, you know, if it's a multiple choice, it'll be pretty straightforward. If you have to explain it, like I said, there's 4 FRQs. I'm not saying this is going to be one, but you should be ready to explain it, all right, just in case. Or sometimes multiple choice questions are long form questions where you have to pick the correct explanation. So make sure you're either or both able to pick and choose the correct explanation or be able to explain it yourself, okay? And a drawing is fine, explanation is good, and words would be wonderful as well. So a question like this says an object is charged. Should we just assume it is negatively charged, like on the test? Maybe, yeah, I guess so. That's pretty yes, because if it mattered, it would specify. So for you to figure stuff out, I would say, yeah, you could assume it's negatively charged and then work out whatever explanation works for you. Okay, a balloon is going to be negatively charged for the reasons that we talked about in class, where that's just the material of it tends to attract negatives. But yeah, that's a good question, Noel. And I think on the test, they're a lot more clear. My question here probably should have had negatively charged balloon. All right. So when you rub a balloon on your hair, it becomes negatively charged. What happens to your hair? We don't really understand the inverse square though. Oh, you know what, Chloe? I am going to come back and talk to that in a few minutes, actually. Okay. So I will talk about that one. I will go back to this really quick though and just point out that I mentioned the inverse square law because these electrons are farther away now. And so they're going to feel exponentially less force than the positives that are sitting around here. Okay, so the positives are going to pull with exponentially more force than the electrons because of their distance. So I'll come back and explain that a little bit better. Okay, good. And I apologize. Apparently it's that season where I get like sore throat. All right, so what happens to your hair when the balloon becomes negatively charged? Or the rabbit fur, or whatever you charge the balloon on, what happens to it? Well, A is pretty vague, and it's also wrong. Your hair is not going to be charged negatively. That's just not how it works. All right. Your hair gains protons. Well, right there, that is just not possible, as we discussed earlier. A lot of you guys are saying D. This is just kind of nonsense I made up. That is definitely not true. It doesn't cause electrons to come to the surface. So yeah, it's D. Nice job. Yeah, so your hair loses electrons. Basically, you know, your hair, hello. You got like hair like that. Haha. Actually, let's make it longer. Oh boy, what am I doing? I don't know why I'm drawing. Your hair loses electrons and the negatives go over to the balloon. I don't know why I'm drawing this because I can't draw. So there goes your hair and it loses electrons. So because it loses electrons, those are supposed to be electrons, there's leftover positives in your hair that don't have electrons to cancel them out. And so because your hair has all these leftover electrons that, or protons that don't have electrons to cancel them out anymore, we can just consider that negative, or we consider that positive because, well, that's just what happens. So those electrons had to come from somewhere. We'll put it that way. All right. Good. All right. Nice, easy math question. Is Bob right? Yeah, look at that. Happy little hairy guy. So an atom has 33 protons, but it has a -3 charge. How many electrons does it have? I am right. C, C, C. All right, so think about it this way. If it's neutral, it should have 33 electrons, right? To be neutral. But because it's -3, that means it must have gained 3 electrons. And so you are right, that is 36. It is letter C, okay? So just start with what it should have to be neutral, and then either take away electrons to make it positive or add electrons to make it negative, and you'll get the right answer. All right, everybody's second favorite questions. So you know what I'm going to tell you. Well, if you're in my class, you know what I'm going to tell you. You have to write the chart for these. So I'm going to go through the chart with you. And you have to be able to do this chart because you are way more likely to get it wrong and forget stuff if you just try to do this in your head. All right. So it says X, Y, and Z, blah, 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 blah. Okay. It starts with balloon Y. So I'm gonna start with that with my chart. Balloon Y is negative. All right. This one's gonna be a little bit easier one than some of the other ones. But you gotta start with whatever balloon it tells you it's negative. And it wants to know A and C. Awesome. I don't know yet, but let's see. Let's see. Keep them coming. Keep them coming. Go faster than me. That'd be great. That'd be wonderful. And it wants to know what balloon Z is going to be, but balloon Y does not interact with balloon Z. So we have to figure out what does Y interact with. It interacts with X, and it attracts. So if Y is negative and it attracts to X, then X has to be positive or neutral. You just got A. All right, let's find out. And Z then does interact with X, and it's repelled. But how do we figure that? Well, let's just figure out. We got to figure out both possibilities, right? So, okay. So if X is positive, then Z, to repel it, has to be positive. If X is neutral, well, that doesn't work out because it can't happen. So you're right. It is just positive. Good. Good. Because, yeah, neutral doesn't repel neutral. Neutral would just dangle there. It wouldn't do anything. Good, good, good. All right. But we're going to see this again in a second. You got to start to figure out both possibilities. Okay? So this is the one, and I purposely chose a difficult one because I wanted to show you the full, the full thing. Okay? On the concept builders, you would have to figure out each and every charge. Obviously on the test, we'll see, okay? But be able to figure out each and every charge just in case. Now, so it's the same idea here. A is positively charged, okay? And it says object A and B attract. So in order to attract a positive, B would have to be negative or neutral, all right? I'm gonna go slightly slow so that if you're doing this, you can be slightly ahead of me, all right? So we have two possibilities for B, negative or neutral. C, it says they repel. All right, so once again, we get our little choices here. If C and B repel, then this has to be negative. And like we just said last time, that can't be true. So we know B now is negative, we know C is negative, and it says D attract each other. All right, actually there's no E. So possibility that they attract, this would have to be positive or neutral. And that's the end of the line. So yeah, you guys are right. It could either be positive or neutral for D. All right. So once again, you just got to go through all the possibilities like that. And this, you know, is either possible there. All right. Are there any questions about that first part, electrostatics? And we are going to get into the inverse square law momentarily, but specifically about protons, neutrons, charges, these types of questions. Okay. You'll see balloon type questions. You'll see maybe these type questions. But I think you know the trick to these type questions. You just have to write it down and explore every option. Aiden, you are correct. Nice job. Very fancy pants of you. Very good. Very good. All right. Seeing no questions, and I'll come back if I need to. Whoa, hello. What? That happened last time too. I'm not sure why I skipped ahead like that. Let's not do that, because I've got a lot more. I just pushed a button and I'm not sure what happened. Let's just escape. All right. We're doing this again? Arg. Oh. Well, apparently I don't know how to do PowerPoint. So we'll just do it that way. All right. It's okay, Aiden. I was struggling there, so it worked out. All right, these types of questions. Excuse me. So while I'm changing the color of the thingy, think about it. Which one is it? Which one's going to experience the most electrical force? All right. So we did this as an opener in class one day. I don't think it was the same exact one. And it just has to do with the fact that a charge is going to be a direct relationship, whereas the distance will be the inverse square relationship. So we're getting a C. So that's a very, we're going to find out. And that's a great like first guess because it's so close. All right. So we got to take the charge into account though too. So it might be A. Let's find out. So this is going to experience 4 times the charge because it's got it's going to experience 4 times the force because it's got 4 times the charge. But because it is 2 units away, 2 units away will be, because of the inverse square law, will be 1/4 the force. So you take them together, and this is going to be basically experiencing one times the force. It's going to be experiencing the same force as regular, or as like as our baseline. Letter B, you're still saying A. Oh, nope, somebody deleted their comment, probably for the best. Is going to experience 8 times the force because of the charge. It's a direct relationship. And letter B is going to be experiencing, well, we got 1, 2, 3 units away, so it's going to be experiencing 1/9 the force. And so the FE, the force, is going to be basically 8 times 1/9, so 8/9. And the decimal of that is going to be pretty decently close to 1, but 0.889. So 0.89 times the force. Okay. I'm changing my formats here. And so when we look at the other ones, it's the same idea. Well, times FE. All right. So this one, it's going to experience 2 times. And again, we're going to ignore the negative. We're just worried about the force, the magnitude of the force, not the direction of the force. So it's going to experience 2 times the force because of the charge, and it's going to be experiencing 1/1 squared. So it's going to be 1 times the force because of the distance. So FE here is going to be times 2. So far, C is winning. This one has 12 times the force because of the amount of charge, but it's got 4 units of distance, which means it's going to experience 1/16 the force. So we multiply those together, 12 times 1/16, so 12 divided by 16, I get 0.75. So this is not even going to be close here. But see how you could quickly, like, I'm explaining it, so I'm going a little bit slower. So it looks like of all of these, letter C is going to be experiencing the strongest force. And you can see it's because of the distance. Now, I'm going to talk about inverse square law a little bit in a second. But actually, let me just, here, there's this chart I made. If you change the distance and you compare it to the electrical force, if you're at 1 times the distance, just pick a distance and you're at 1 times that distance, you're going to experience 1 times the force. You're going to experience a certain amount of force. If you are half the distance away, if you get closer, you cut the distance in half, you're going to experience 4 times the force because of how the inverse square works. All right, let me do a couple more examples and I'll show you. You'll see the pattern, okay? If you're at 1/3 the distance originally, you're going to experience 9 times the force. And the pattern keeps going. If you're at 1/4 of the distance, you're going to experience 16 times the force, and so on. All right, and the reason is the inverse square. You inverse this, so 1/2 becomes 2/1, and then you square it, becomes 4. 1/3 becomes 3/1, and you square it, becomes 9, and so on. If you increase the distance, say you double the distance, well, the inverse of 2 is 1/2, and then the square of that is 1/4. So you're going to feel 1/4 of the force if you double the distance. If you triple the distance, you're going to feel 1/9 the force, and so on. 4 times the distance becomes 1/16 the force, and the pattern continues. So 5 times the distance, you're going to feel 1/25 the force. So that's an example. That is the inverse square, what you're seeing here. And the name of this pattern is inverse square. You'll see a graph of it later. And this just shows the relationship that scientists have measured when they change the distance between 2 charges. All right. So, excuse me, back to the question. Next question, which is going to experience the least amount of electrical force? Well, let's not do all that again. Let's just go back to our previous one, and it looks like letter D is going to be the winner there. So I'm going to go over here, and I'm going to magically circle letter D without any explanation, except say, go back a slide, and you'll see that if you take that all into account, that experiences 3/4 of the force compared to everybody else is experiencing different amounts. Okay. So those questions I noticed on the quiz that I gave, questions that it looked like this, I think, yeah, here's another one, had some issues. Yeah, D for sure. Okay. Aiden, am I lagging or is that just a you thing? Let me know. Let me know if I'm lagging. Well, we'll see. So we're going to do the same thing here. This is it looks completely different, but it's actually not. I remember during the test, a lot of people were asking me questions like, how do you know distance? Well, if you see something like this, just make up a distance. Like this is very clearly like a certain distance from the charges, and it seems pretty clear this is double that distance. And here we have the same, well, I can't draw a straight line. That is going to be a certain distance. Got it. Awesome. And this is going to be double that distance. So the direction is not going to matter. It doesn't ask about direction. It doesn't ask if it's pushing or pulling. It's just asking which is going to be the strongest. So all I did was I sort of took I made these little lines that are here, and I just made my own lines. All right. And now I get a really good idea that, like, for example, why can't I draw? This right here is going to be a certain distance from the charge. And these over here are going to be double that distance. These over here, it's the same, same thing flipped, but it's just looking at the distance and comparing those. So what's the question asking? In which situation would the small negative charge experience the strongest electrical force? So it's a lot like the question, this one from 2 times ago. And we just really quickly, hopefully can do the same thing. So This one's experiencing 3 times, we'll just call it 1. Let's not even like mess around here. 1 times the distance. So it's going to experience 3 times the force. We got a distance of 1d, whatever the distance is, 1 distance unit. And so for the distance, it's going to experience 1 change in 1x of the force. And so the total force it's going to feel is going to be 3 times the force. 3 times the force, whatever it is, 3 times Fe. This one is going to be 6 because of the amount of charge. And then because the distance is also 1, it's in the other direction, but it's still just 1. So it's going to feel 1 times the force. 1 over 1 squared is 1. And so this one's going to feel 6 times the force. Okay. All right, let's take this one then. This, because it's going to feel 3 times the force, but then it's got 1 unit of distance, so it's going to feel 3 times 1 again. So this charge is going to make a 3 times the force. But then we got this one here, and honestly, it's easy to overthink this. We might be overthinking this, but it's probably okay to do this. So it's going to experience 3 times the force again, but it's going to be negative. And now we kind of have to deal with that, but because of the distance, it's going to be double the distance. So if you go back to this thing, if we double the distance, well, that's going to be 1/4 of the force. And so it's going to experience negative 3/4. So we're going to add these together. It's kind of, like I said, it's a little confusing. So we got 3 minus 3/4. So this is going to be experiencing 2 1/4, so 2.25 times the force. All right. I realize I'm losing some of you here, but just bear with me here. This is basically how it's got to go. And like I said, just ask me if you're not sure what I'm doing here. All I'm doing though, and I'll just explain it with this one, because of the +3 charge, it's going to feel +3 force change in the force increase. Because of the distance, it's only 1 unit away. It's going to experience 1 over 1 squared times that. And so the total here is going to be basically a +3 to the right. Over here, we got a -3, and it's double the distance. So it's going to feel 1/4 of that. So this is going to be a negative 3/4 of a charge. And it gets a little confusing because, well, this is negative, but it's on the other side, so we count that as a positive. So when we add those together, I mean, you could just sort of, all right, so 3 plus 3/4, so this is going to be 3.75x. So we're winning so far with it. No, we're not. This guy's still over here. I think we could pretty much just call it, okay? So you get to this point and you realize you're doing all this crazy math, and you had a probably a really good, reasonable like choice. So let's say you're taking this test on Friday or whenever, and you get a question like this, and you're like, oh, what do I do? All this stuff, Mr. Jones sort of kind of explained it. I barely followed it. What do I do? What's the most important? What's going to have the most influence on a force? Well, it's going to be distance. This thing is like super close, and it's got a bigger charge than this one. And it's going to end up being B. I mean, it's a reasonable choice to choose B. Let's just prove ourselves right, because this is going to be 6 because of the charge. And because of the double the distance, it's going to feel 1/4 of that. And so what's I don't even know, 6 divided by 4? 3, hang on, 6 divided by 4, just to make sure. Yeah, 1.5. So it's going to actually only experience 1.5 times the force. Okay, so after all that, I probably could have just looked at this, said, well, I mean, this thing's really close. It's got a pretty decent sized charge, and I think it's going to be the winner. And so if you do look at this and you have to make a guess, look at the distance. All right, that one out for this one. If we go back, like, look at, we did all the math and it ended up being the closest one. Now, if you know how to do the math, double check. Okay. This one was the farthest. Check that out. I mean, I did not, like, that's just usually, a lot of times it's going to be how it's going to work. Okay. The farthest away has the weakest. The closest one has the strongest. This one, it's like, well, we got a couple close ones. Yeah, but this one's really far away and it's not going to double, you know, like, kind of use some reason here, but use your best logic for this one. All right. And maybe save it for last if you're on the test. All right. Somebody say hi, because I'm not sure if I'm talking to myself here. That was a long ramble, and that was probably, yeah, the most, who knows. All right. Nobody's saying hi. I wonder if I'm still streaming. I am. What do you know? All right, cool. That was just a lot. Oh, look, graphs. Okay. Okay, how did I get 3/4? Which one was that? Awesome. Thank you, guys. Good. That was a long one. 3/4. Where did I get 3/4? It's okay, Chloe. This is why we're doing this. Tess, what's up? You guys are awesome. Ooh, blow out the speakers there. So 3/4. I got a 3/4 here. Let me know which one, A, B, C, D, or E, Chloe. But I got the 3/4 here because I got the 3 from the charge. I got the 3 from the charge and the 1/4 from the distance because it's double the distance. So it's going to be awesome. It's going to be, 3/4 multiplied together. And I got a 3/4 over here because, once again, it's actually the same thing except on the other side. 3 times the charge, so I'm going to get 3 times the force. But I'm going to have double the distance, so it's going to be 1/4 the force from that, multiplying together, and you get your 3/4 there. All right. I think that's the only 3/4 I got. But let me know if what else there might be. I'll gladly come back and explain it because this one is confusing. All right. What it boils down to is distance has an exponential effect on the amount of force that something's going to feel, electrical force that something's going to feel. The charge has a direct effect. So they go together, you multiply them together, and that's how you get you multiply them, yes, you multiply them for that particular charge. Like, for example, for these ones, you multiply the 1 and the 3. For these ones, you multiply the 6 and this 1. Multiply these together because they're the same, talking about the same charge. But for these, I added right here because we're talking, or actually ended up being a subtraction because we had a negative number, because we're talking about 2 separate charges. So yeah, you multiply them when you're just like these we multiplied here. These we multiplied. Because if you look at the equation, they just go together in the same equation. So yeah, multiply to get the total change in force due to charge and distance. All right. Okay. All right. Let me know if I need to go back to that. So, Coulomb's law. Okay. Just talking about Coulomb's law. Using the terminology, the words, whatever. What's true about it? Now, this is obviously a long question, but what's true? Is force directly related to the distance between charges? Well, Coulomb's law here, let me just write this out. This is Coulomb's law. This is basically the equation that describes everything we've been talking about. K Q1 times Q2 divided by distance squared. All right, so that's the equation. But you don't even need to know that. It's nice to reference it because this is where we get the inverse and the square for the inverse square law, because D is on the bottom and it's being squared. And the reason that Q is proportional or directly related is because they're just on the top being multiplied. So force is related to, yes, B is correct, but there is another. B is correct, but there is another. All right, it is not A because we're talking about distance. What about the magnitude of the charges? Square the magnitude of the charges. Yeah, it is also C. So this is going to be the distance, which is the squared one. The magnitude of the charges is going to be another way of saying Q. What's the size of the charge? How big is the charge? What's the magnitude of the charge? So that's what that's dealing with. All right. Oh, I probably should have wrote that up here because That's why this is wrong, because we know it's not the inverse of the square for when it comes to charge. All right. So when it comes to distance, inverse square. When it comes to charge, it's directly or proportional. Sometimes you'll see the word proportional. I'm not messing with that. And now I messed it up. Proportional. That looks kind of sort of right. Proportional is another word you'll see instead of directly. All right. I don't get the fancy little red lines that tell me if I spell it wrong or not. All right. So I know at least in my class we did that experiment, and it had to do with changing the. It was when I was 6, so like I don't know how much we remembered from that, but you had to change the force. You had to change, and then you saw how you changed the charge, and you saw how it affected the force, and you made a graph, and then you changed the other charge and proportional. Did I spell it right? Yeah, I did. I guess I did. I'm going to say I did. And then you changed the other charge and saw how it affected the force. And then you changed the distance or the radius between the two charged objects, and you saw how it affected the charge or the force, and you made a graph. So which of these shows an inverse square relationship? In other words, which one would show the relationship between distance and force? And it would be D. That is correct. That is correct. Okay. This one here, this is inverse square. Inverse square. In other words, 1 over x squared. This is just a squared. That's just x squared. So there, we don't have anything to do. This is a, I guess you'd call it inversely proportional, letter B. And this is just proportional. As one goes up, the other one goes up. This one right here is as one goes up, the other one goes down. So I think inversely proportional is the correct way to, but they're both linear, but this is the answer. This is inverse square relationship. All right, got that curve. As one gets bigger, the other one gets exponentially smaller. That's really what you're going for. Okay. If the distance between two charged objects quadruples, what happens to the electrical force between them? Has it been almost 45 minutes? Wow. What happens as the distance quadruples? A, B, C, or D? All right. Well, hopefully you know it's not going to be with this one or that one. Or that one. Yep, it is going to be D. It is going to be D. That's because look for the keyword distance. When you see distance, I'm talking about charges or mass and gravity. Yes, that is the inverse square. So 1/16. Great. Great, great, great. If the distance between the charges is 1/4 of what it was, what's going to happen to the electrical force between them? Still talking distance, but now it's 1/4. Just to stick to the theme of 4s. Yes, very good. It will be C, because again, we're talking about distance. And so we got to do the inverse square. So 1 over 4 becomes 4 over 1, and then you square it. Wonderful. You guys are awesome at this, I think. Now, we are talking about the charge. So the charge of one of the objects is quadrupled, but the distance stays the same. Okay, so you might not have these fancy graphics going on when you see questions, and they might be asked slightly differently, but we're asking about the charge. And it's quadrupled. And quadrupled means 4 times the amount of charge, as you can see in the diagram that I just whipped up. Okay. Yes, great. It is going to be A, because that's the proportional relationship, or directly proportional, linear. As one goes up, the other one goes up exactly the same amount. You guys are awesome. What if the charge of both objects is quadrupled? What's going to happen now? It's multiple choice, so you have an idea here, but I'm willing to bet most of you are going to eliminate D right away. And you should, okay? Because the force should definitely get stronger. Well, here's what happens. And let me explain. You're good. You're good. All right. So this is going to get 4 times as strong. And this is going to get 4 times as strong. And in the equation of Fe equals K Q, holy cow. That's supposed to be a Q, ladies and gentlemen. Q1, Q2 divided by distance squared, you multiply these together. So you're going to have to multiply these together. And yep, it is definitely going to be B. Okay, so that's just how it goes. So if when in doubt, maybe the equation can help you figure out what to do. But yep, they're both 4 times stronger. So you multiply them together, you're going to get 16 times the force between them. They're going to pull together or repel each other with 16 times the force. Okay, I needed to touch on the math. And math and these live stream reviews don't go so well together. All I could say is you need to make sure you practice the math. All right. These are pretty straightforward. And here's why I bring it up. On the equation sheet, let me just pop the equation sheet over here. On the equation sheet, you're going to get these equations right here. Okay. And I told you in class, this one's not going to be used. Okay. So you can just forget about that one. This one very clearly has to do with gravity. So whenever you see a question asking about mass, can I zoom in even closer? Oh, there we go. When you see a question talking about mass, then or gravity, then you know it's talking about gravity, all right? And then you've got this one, and now we're talking about force, the electrical force, and we've got Q1 charges. So if you're talking about charges and forces, you're going to be dealing with this equation. If it's talking about charges, just like this one, but no force, and it's talking about like the number of electrons, that's what this N is all about here, okay? This E, well, to see that, you gotta look on the front page, right in the front under constants. So here is our charge constant, okay, this is just review for the thing. Here's our G for the gravity one. And then here's the speed of light, which we don't talk about right now. And then here's E, that is the charge of a single electron. All right, so just so you know, when you choose an equation, those are the 3 possibilities, and you gotta just know what they're talking about. So we have a force between a charge, charge, another charge, hello, oh, that's a fancy little line there. And we're talking about a distance here, and it wants to know the force. So guess which equation we're gonna use? It's not gonna be this one in A. All right, so I'm not going to sit here and ask you to do, I want to erase. I'm not going to sit here and ask you to do math with me on the live stream, but we've beat this to death in class with the calculator. All right, just be very careful, use parentheses. Most of you are pretty good with this, I think, okay? And the answer, honestly, I don't remember, so I'm going to put it in my calculator really quick. Yeah, I don't remember. So I'm going to do, I kind of wish I could do, it is a D. You know what? Now that you say that, I think you're right. I'm going to switch over to this webcam or this other one and put in my other calculator. And so I'm going to do 9. Uh-oh, this calculator is not like the one I have at school. There it is. So 9 E 9 times, that's not good. It's going to yell at me if I do that without that. Okay. Times the first charge. And I know I don't have it up on the screen anymore, but it's 4.3. I should just take your word for it. That's D. Most of you are getting D. Times the 2. And if you put in your calculator, actually, you should be able to do this yourself too. So 5.0 E negative 8. Okay, once again, just get used to putting all that in there. And they are a distance of 2.5 E negative 3. And don't forget to square it, ladies and gentlemen. So 3.9 times 3.09, so 3.1 times 10 to the 10th is going to be what I want there. So 3.9 times 10 to the 10th. It's going to be C. It's going to be C. Ooh. Where am I at? There we go. It's going to be C. So what did you guys get? You guys got D. I think, let's do that again. I wonder what happened. Let's see. Let's do that again, but let's not square it. I bet that's what it was. Then I'm going to change my thing to scientific notation. All right, I've told you, and you've seen it. Yeah, 7. Okay. Yep, we all forgot to square. You guys who said, if you said D, it's because you forgot to square it. Sorry, guys. But seriously, I told you in class, and I'm telling you again now, and you just saw it. It's super easy to forget that square. All right, so definitely don't forget to square it. And I was super sneaky tonight because I put that in there on purpose for that reason. I'm glad I didn't just go with what you guys were saying, but that's why I put it in there. All right. So just watch out for that. Excuse me. Watch out for that square at the end. Okay. The distance between two spheres, one with a charge of. Okay. So one thing I didn't hit on my review guide, and I should have, and I don't know why I forgot to do that or didn't put it in there, is be able to, when you see a question like this, I mean, it's talking about the two charges. And it tells you the force. So K, Q1, Q2 divided by distance squared. Be able to solve for distance, be able to solve for a charge. Okay, I know it's on the practice. I think it was practice 2 for my class. So make sure you could do that. Make sure you could solve for these. And I think I remember the answer, but I'm going to put it in the calculator as well. So I'm going to put it in, and then I'm going to show it to you because I'm going to leave the screen up so you could try it out yourself. But now the way I have it written here, I have it written rearranged beforehand, and I did that just for the live stream. And I know that most of us are plugging in numbers and then rearranging it, but like I said, the live stream doesn't go very well with doing math problems online. Let's keep that. Wait, I'm going to go back to that, so don't worry. I just wrote my answer down, and it is going to be, well, you probably just saw it. So yeah, if I plug those numbers in correctly, if you plug those numbers in correctly, you're going to get choice B as the answer. All right. What I'm going to do is I'm going to suggest that if you're watching this, maybe go back to this part and try it out yourself. So we're at about 51 minutes in. And so remember that and come back to it and try it out. Put it in your calculator. Make sure you get it correct. Okay. So honestly, I think I took this from the review guide, or I took it from one of the practice problems or something. So we might have seen this one before. All right. So don't forget to square root at the end. Now, somebody asked me yesterday or today, how do you know when to square root a question? Well, what you need to do, doesn't matter if you arranged before. No, it does not, Chloe, at all. And this is a discussion that we kind of had in class, is what do you do? What are you comfortable with? All right. If you're comfortable with rearranging this equation first, do so. If you're more comfortable with plugging in all the numbers and then solving for the leftover variable, do that. Either way is going to work just fine. All right. So it'll work just fine. Doing this or doing it this way, rearranging first, will serve better in the long run if you go into a math or science career or major even. But if you're just trying to get through physics, then just do whatever is comfortable to you. All right. And maybe don't change things up right before a test. All right. So yeah, so you do what you got to do. But yeah, what were we asking? So what's the distance? So basically, because the distance here, I'm going to go back to this thing. Nope. Holy cow. Why can't I PowerPoint? What in the world? This thing just likes to skip around a lot. I apologize, guys. I really don't know why it's doing that. So weird. Gravity questions. Nope. There we go. All right. If we go back to this one. Yeah, good. I'm glad. All right. So if you go back to this equation, if you're trying to solve for distance, the question's asking you to solve for distance is when you're going to have to square root at the end. And the reason is because of the square here. If the question's just asking for a charge, there's no squared, like you don't square the charge, so you're not going to have to square root to get the answer. Okay. I think this seems to be the last one for this unit, part of the unit. So I couldn't think of a really great way to ask this in a multiple choice way for the live stream review. So what I'm going to do is I'm going to do a little Bob Jern here and draw for you and sort of explain it. But these are the general tips that I mentioned in class. I like to start with 8 starting points. Now, these are just general tips. I'm not going to be looking for the fact that you start with 8 starting points around each one. It's just 8 is a good number because it really tends to fill the page there. And it just kind of gives you a place to start. And you got to remember that when the lines, when you draw your lines, start from a point and head directly away from the charge that you're starting at. And then basically you add your lines, and you know, any interaction is going to cause curving, either toward or away. All right. And then add the arrowheads. Okay. So I'm going to do number 2 now. So I'm going to start by going directly away. Now this is a positive, and so it's going to be influenced by this negative over here. It's going to get curved toward it, and I'm drawing on a pad, so that was a little sloppy, but that's basically what you want to do. This is going to get pushed away from the positive. It's going to come back around. Oop, I got off the paper, and apparently I'm just going to kind of follow that along. And, you know, there's no like one way to do it. This is going to get probably curved around as well and eventually make its way over there. So, you know, just kind of fill the page up, go all the way to the end. All right. Starting going away from the positive, or it's going to start by trying to get away from the charge and head toward the other one. Now I got to start thinking, all right, there's another negative down there. What's going to happen? It's going to start to get pulled toward that one, I guess. Okay, this one's going to head away and get pulled toward it. And I apologize again, I'm not drawing with a pencil. This is a little awkward for me to draw. Pushed away, but then it's going to get pulled toward this one. Okay, this one's going to start to get pushed away, and it might get pulled toward that one, but it's going to probably get pushed away by that one a lot. I don't know. That one's actually kind of iffy. I don't like that one. Okay, feel free to erase your stuff. I would definitely bring a pencil. I guarantee you'll see a question like this on the test where you had to draw. All right, so this gets pushed away and then like gets deflected or repelled by the other one. It starts going away and gets pushed away. All right, I'm kind of going quickly too because, you know, time. This one gets pushed, like it starts to head out from the negative, and then it gets pushed, it gets repelled by that one below. All right, it starts to come straight out and gets pushed away by the one below, and so on. It gets pushed away, and that one actually might curve back around toward it, but you get the idea. All right, just sort of let your imagination run. What would it do? Look around. What's influencing your pencil tip as you draw? All right, now I'm going to draw the arrowheads. What would a positive charge do? Well, a positive would move away from this positive, move away from that, move toward the negative. All right, move away from positives and toward negatives is what a positive charge would do. All right, so all my little arrowheads, I'm not going to necessarily do every single little line that I drew because I don't want it to look sloppy. But away from positives and towards negatives is basically what I'm going to do. So here's are the rules, and these are the hard and fast things. Do not cross any lines. If you do, that's a point. These things don't cross. And make sure your arrows are pointing away from positives and toward negatives. All right. That's how you do these. It's sort of an art, and I'm not looking for art. I'm looking for basically you're following those rules and you're basically following the general tips I gave you. All right. All right. Any questions? Because we're going to move on to gravity. And I always think, oh, this will take a half hour, 45 minutes. I'm thinking it will be another 15 minutes. All right. Well, let me know if you do have any. All right. Which of these does not exert a gravitational force? Gravitational force. A black hole, the sun, the moon. I'm getting smaller as you go down. An asteroid, you, a fly, a speck of dust, a proton, an electron. Well, anything with mass will have a gravitational force. And the only thing that, well, see, an electron, the only thing that maybe can be argued that doesn't really have any mass is maybe an electron. Okay? So if I had to choose one, that's the one I would choose. Everything else has a gravitational, or exerts a gravitational force. Everything that has mass pulls on everything else that has mass. All right? Bottom line. More mass, it is I. More mass, more gravity. That's all there is to it. So a single proton is not going to pull very hard at all. You're not pulling very hard on the things around you at all, although you are pulling on the Earth. And you're pulling on the Earth with about 100, 150, 200 pounds of force, because it's pulling on you with that much force. Proton has mass. That is a phenomenal question. Although I'm not going to ask why a proton has mass, because that's a little deeper than we want to go here. But I will just say this. When you have all the protons and neutrons and junk in the middle, those, and then you got the electrons swirling around the outside, okay? This part with the protons and the neutrons, that's where all the mass of an atom is at. That's going to be the dense part of an atom, okay? And electrons really don't have much mass to speak of. Like I said, we could go back and forth whether or not yes or no, but I'm just going to, for our purposes, say basically no. But that's where all the mass is. All right, that's where the stuff is the protons in the middle and the neutrons, but they don't have a charge. So I didn't mention those, but it doesn't matter if they don't have a charge. That has actually nothing to do with gravity, so don't get confused there. The neutrons actually have gravity as well because they have mass, and the protons do too. So it's more the nucleus than the proton. Yeah, but that's like that'd be like saying that it's more the class has gravity than you. It's just, I mean, why does the nucleus have gravity? It's because all the individual protons and neutrons have gravity. You know what I mean? It's just now you just pile them together and they all add up. So yeah, but yeah, the smallest thing that I mentioned here that has mass is going to be our proton. That's a bit. Just remember, anything that has mass has a proton. I tell you what. To be fair, this isn't chemistry, so I'm not going to be asking about the mass of protons on the test tomorrow or on Friday. So as long as you're, yeah. If you're not sure, you can just ask me, does this have mass? And then I'll say yes or no. All right. Okay. Dog, cat, gerbil. I'll give you about 30 seconds. Set a timer for 30 seconds, please.
Your timer is set for 30 seconds.
Don't think too hard on this one. And I won't judge much. I'll just give you extra credit. And I bet we can... Noel, one answer, please. One answer. Holy cow, Noel. I probably can convince your teacher, if you don't have me, to... oh, there's your timer. To give you extra credit if you want to answer that. Monkey. Noel. All right. If you had to pick something, Aiden, that's fine. If you had to pick something for extra credit, awesome. Awesome. I won't invite my dog to our little party. She tried to barge in earlier, but yeah, I shut the door just for the credit. All right. I will, I'll keep that in mind, Aiden. All right. Oh, there goes my phone. Good thing I don't have a case. All right. So, almost done. Which of these are true about the relationship between gravitational force, mass, and radius, aka the distance from the center? Choose all that apply. We've seen this question before, but in terms of static electricity force. I don't know. Monkeys annoy me. I feel like they'd be just like getting into everything and like, basically making a mess of everything. And I don't know. Pet monkey. Yeah, I guess it'd be fun for a few minutes. But I don't know. That's just me. Well, similar to before. If we look at a gravity equation, Fg equals capital G, M1, M2, and the distance or the radius squared hedgehog. What the? I don't even know what a hedgehog would be like for a pet, except from all like little videos and I'm going. So force is directly related to the distance between the objects. So that is definitely not true because I mean it's distance, and if we know anything about distance, it's going to be the inverse square. All right, so we look at this one. Yeah, not D. Well, let's see. So we got distance involved with this, and inverse square. Yes, that is definitely true. So B is going to be at least one of our choices. So sorry. Yeah, you were right actually originally. Wait, you said B, not C. Oh, okay, got it. Okay, yes, B and C. Well, let's see. Force is directly related to the mass. Well, just like with charge, yeah, we're talking about mass. If you replace mass with the word charge, then this is true, and it's true for both of these. And here we got our inverse square for mass, and that's just not true. So so it's B and C. All right, so once again, I mean, if you know this about charge, then static electricity, then you're going to be good with gravity for this. It's the same thing, just replace the force of gravity for force of electricity and replace mass for charge. All right? All right. All right, here's a weirdo question, and I bring this up for one or two specific purposes. The Earth's mass. Boom. That's going to be mass. We'll just call it M1, right? What is the mass of the moon? Well, I guess we'll call that M2, and that's going to be our unknown. The heck is 60 of Earth's radii? All right. Well, here we got a force. Well, that's going to be our FG. I'm sure this should be a bigger capital G. That's going to be our FG, the force of gravity. So we look at Fg is equal to, is it capital G? No, I'm not 100% sure. G m1 m2 divided by distance squared or radius squared. So we got the word radius, and that's a little odd, but that is a distance. And so it's like, well, how do I know what even the Earth's radius is? But if I pull up the equation sheet again, and I zoom out so I'm not ridiculously close, let me just do one of these things. Go away thing. Oh, how if I click on the actual word and not on the go away? Okay, let's actually zoom out a little bit. I just want to point out that the mass and radius of the Earth are on your equation sheet. It may or may not come in handy, and I'll point it out in class before the test because it's going to come in handy. All right, so the radius of the Earth is, now I got to do one of these things. 6, I don't actually have it memorized. Maybe I should. You know, it's going to disappear. So I'll scooch it over where you can't see it, but I can. All right. So the radius of the Earth. So the radius of the Earth is equal to 6.38 times 10 to the 6 meters. Okay. So I'm just writing that down from the equation sheet so that I don't have to keep this up here. Okay, doop doop. I'm gonna close it and minimize that. All right, so what do we do? Well, here's what we do. We plug in our numbers, all right? So I'm gonna do it like you said earlier. The field of force of, I'm gonna use this equation. So the force is gonna be 2.0 times 10 to the 20th newtons is equal to G, and on the equation sheet, G is going to be 6.67 times 10 to the negative 11th Newton kilograms squared per, I messed this one up. No, kilograms squared is on the bottom, and that means that meter squared is on top. Okay, definitely have your equation sheet on here, although it's whatever. And the mass, so M1 is 5.98 times 10 to the 24th kilograms. And we're trying to find M2, the mass of the moon. Okay, now what's the distance? Well, the distance is, it says 60 of Earth's radii. That means that, well, it means exactly what it is if you think about it. Like the moon is, if you take the radius of the Earth and multiply it by 60, that's how far away the moon is. And that's not a lie. That's literally how far away it is. It looks so much closer than that. And it's not. It's really far away. So the distance is going to be a little weird. It's going to be 60 of the Earth's radii. So I'm going to take the 60 times 3.8 times 10 to the 6th meters. And I got to square that distance. Okay, well, all right, cool. This is a mess, but if you're good with your calculator foo, then you're going to be fine with this. All right. And so what I'm going to do is I'm going to multiply both sides by the stuff on the bottom here. All right. So in my calculator, I'll type it up in my calculator and I'll put it on the thing so you can see it. I'm going to do 60 times 6.38, and I'll go slowish so you can try it yourself. This is another one you're going to want to try yourself. E to the 6th, square that, and I'm going to multiply both sides by that. So 2.0 times 10 to the 20th. Okay. Let me just put that up on the monitor really quick. So that's what I got when I took the 60 times the Earth's radius. I squared that, that's my distance, and I multiplied that by the force. So 2.0 times 10 to the 20th. That's all I did. So, and that was just because I basically used this equation, and I just multiply both sides. So now I'm going to I need my calculator again. So when I multiply both sides by that, I end up with come back. 2.9, and I'll round at the end, times 10 to the 37th, and it's going to be Newton meters squared equals, and now I want to multiply here. Let me just do kind of indicate what I'm doing here. Let me switch colors because I know I'm maybe going to go a little slow on this one, but green. Oh, great. I picked green. Sorry if you're colorblind. So I took this and I just multiplied both sides by the bottom of that, and that gave me this. And I'm going to take, let's do orange. So now I'm going to take, where'd my pen go? Pen. There we are. Oh, it's orange. I can barely see it. Okay, I'm going to take this. I'm going to multiply all this mess up here. Nope. I'm going to multiply. Hey, erase. I don't want to include this mass, so I'm going to multiply this. Okay. I erased that number. All right, it's not erasing for me. I apologize about this being a little confusing, but I'm going to multiply. I'm going to take all this. I'm going to leave this mass alone, so I'm going to get rid of that. And I'm going to multiply that, and that's going to basically stay right there. So let me just switch over back to my regular pen. I'm going to do the multiplication. I'm doing the multiplication. You guys know how to solve this stuff. I'm just kind of doing it sloppily on a screen, and hopefully you guys are going to do it on the paper in front of you. So 6.67 times 10 to the negative 11th times 5.98 times 10 to the 24th. Okay. And so that gives me 3.9, so basically 4.0 times 10 to the 14th. All right. 4.0 times 10 to the 14th. I'm going to write down over here. Come back. Why did everything? All right. 10 to the, what I get for being fancy. Everything doesn't work sometimes. Times 10 to the 14th. And basically what happens here, one of the kilograms cancels out, and that's about it. So we got Newton meters. Well, that's not good. Come back. Holy cow, did all that just... Well, ladies and gentlemen, that's a shame. Undo. There's no undo. All right. Well, let's see if I could just look at my calculator again. Erase. What is going on? Okay. Well, I multiplied both sides by the bottom. Let me just rewrite that. I believe it was... Holy cow. All right. This is... I'm going to do it over here. 2.9 times 10 to the 37th. And this was supposed to be newtons over here. Somehow that got erased. So it's still newtons, and meters squared is equal to, and then I do the top part. Okay, not the m, and I got 989 times 10 to the 14th. And like I said, one of the kilograms got canceled out. So it's Newton meters squared per kilogram times this mystery mass that we don't know yet. Okay. And so now I'm going to divide both sides by that new number. So wish me luck, because technology is deciding to crap out on us tonight. So 2.9 times 10 to the 37th divided by 3.989 times 10 to the 14th. And that gives me 7.3 times 10 to the 22nd. And then basically what cancels out, these ends are going to cancel out when I divide it. These masses are going to cancel out. And I'm going to be left with kilograms is equal to the mass 2. I really hope that's one of our choices, because I'm calling it. And yes, good. Okay. So that is the mass of the moon. Now, what did I do? Okay. Easy part, not the easy part, but hopefully the easier to understand part, regardless of what happened with all the technology here and all the weirdness. I'm going to try something that probably won't work. Can I erase that? No, it's not letting me erase that. Okay. Regardless of what happened with all this mess and what happened, all I did was solve for the missing variable m. Okay. That I think you can handle if you're given the force and you're given one of the masses and you're given the distance. I hope by now you can solve for m. That's part one. That was the sort of straightforward part. And if you're okay with the math, that's okay. But the other reason I wanted to bring this up is because this 60 of Earth's radii, because we're talking about gravity, that's a fair question. And just look out for that kind of stuff. So if you're looking at the test and you got a question about that, just let me know. Let your teacher know if it's not me. Okay. But you see what I did there? So I basically looked on the equation sheet. I found out that the Earth's radius is this number right here, and I just multiplied it by 60. All right. So let's move on from that. If you have any questions, let me know. Well, hey, I think that is actually the end of it for real this time. Look at all my work. It's all gone again. Whatever. Are there any questions for me? Because that is the end of my prepared remarks. It only took an hour and 16 minutes. Okay. And this is that somewhat corny but very true thing I said earlier today. You might not get it yet. Just put that at the end of your laments or complaints or whatever. You might not be good at this yet. You might not understand it yet. Okay? You got time. No matter whose class you're in, you've got a few days. There's me. Look at my fancy drawing. Happy little cloud. You've got time. All right? So just be patient. Do work through it. And you're going to be fine. Oh, his mouth became a chin. Let's make it. There we go. Okay. So let me or your teacher or anybody know if you have questions. Use the Remind app. Okay. Go through the practices. Go through all that. Maybe go through this, like go back to this and try out some of the ones that I worked it out. Oh, the next try. Okay. Procrastinating. Chloe, that is a phenomenal question. Okay. The K value, and I actually meant to ask one of those questions. Yeah. Yes, I want to keep those because my phenomenal drawings. So that would be, I thought I asked a question about that. What was a force, a charge, a distance. Weird. I really thought I asked one of those questions. All right. Well, I meant to. Yeah. Let me see. Practice. Here's a question you're going to get, and this goes to your question, Chloe. So this is the review guide I gave my class, and I'm guessing Zwartz gave one similar. Whenever you see a question like this, and I think, oh, well, I have it actually right here on paper, but whatever, it's too late. I have it online now. whenever you see a question like this, how much charge does an electron have? The question is K negative? So like this K right here, is it negative sometimes? The answer is, honestly, it's pretty much always negative. We just kind of don't, it's not on there for some reason. I don't know if there's a reason it's not on here, but I feel like that should be a negative because yeah. So if, how much charge, I would expect a negative answer from this, okay? Because it is going to be negative, and you would have to use, can I draw on this? You would have to use, oh wow. You would have to use this equation. Charge is Q times E, or I'm sorry, Q is N times E. And N is just a counting number, like literally like how many, that's how many electrons it is. That's why there's no unit for this. So you multiply it by that and you're gonna get a negative number because it is a negative number. It's a negative charge, yeah. So how many charges does it, how many electrons does it take for an object to gain this much of charge? Now in this question, it's not specific if it's positive or negative. So yeah, I mean, if you're in doubt and your logic fails you, ask, okay? But if you got a question about it, just think it through and you'll probably get the right answer. But yeah, it's a good question. It's a very fair question too. So I hope that answered that well enough. Anyway, the answer is yes. The K is, it should be negative pretty much all the time, and it generally works out. All right. So like this answer, this is going to be a well, it says right here, so this is a positive number, this is a negative number. And so in the end, you're going to get a negative answer for number 19. I hope I represented that on my key, but I should have. Okay. Any other questions? Not procrastinating. Holy cow. Jacob. A, I'm over here doing an hour-and-a-half live stream. B, you guys are over here watching an hour-and-a-half live stream. I don't think anybody's procrastinating unless you're doing other things while you're doing this. Whoop. I gotta say, that's a really nice picture I drew. I like it. Any other questions? Well, my eraser doesn't work anymore. Okay, so then study hard. This, and I'm gonna tell you one more time. I gotta tell you, this live stream, I don't care that we spend an hour and 20 minutes on talking about physics on a Wednesday night when you could be doing something else. A, I know that most of you were probably doing other things while you're watching this. B, this does not take the place of studying. It is, I hope it's helpful. You guys have told me it's helpful, so I hope it's helpful, and I'm assuming it's helpful. But it doesn't take the place of going through and reading and maybe writing and copying the notes. It doesn't take the place of working through the study guide, going back and looking at the quizzes and making sure you completely understand and maybe reworking some of those questions that you got wrong. Okay. When I mean study, studying is not a passive thing. You actually have to actively study. And if you don't believe me, I mean, look at how your tests were. I mean, maybe some of you did good. I don't know, good without studying, but I get the feeling that maybe you could do more. All right. Maybe you can't. Maybe you did do more last time. I don't know. Only you can answer that, but make sure you actively study and do stuff to make sure you get this. I do hope this helped. So how much are you willing to sell that drawing for? $350. So that's basically it. Yeah. 3. Okay. So, all right. I think I've talked long enough. You guys have a wonderful evening. And like I said, if you have any questions, feel free to just shoot me a remind or ask me in class on Friday morning, come early, or you could maybe pop your head in tomorrow during the SIP day. All right. So have a good one and good luck. Study hard. See you later.